Good evening. I'm Yasmin here from CIT with my team. Gonna explain our project predicting the energy output of wind turbine based on weather conditions. So our first slide is we're gonna discuss the introduction, problem statement, tech stack, and flowchart and timeline, and all models and user interface. So we all know renewable energies like wind energy plays an increasing role in the supply of energy worldwide, and wind energy is a key player too. However, the production of wind energy is hard to predict as it relies on the rather unstable weather conditions present at the wind farm. In particular, the wind speed is crucial for energy production based on wind, and the wind speed may vary drastically for the different periods of time. So, energy suppliers are interested in accurate predictions as they can avoid overproduction, right? So, there's a need for examining the impact of different weather conditions on energy output of wind power to reduce the need of additional balancing energy and reserve to integrate wind power. So in particular, we correlated the different components that carries the weather conditions such as wind speed, pressure, and temperature. So for a wind farm that converts wind energy into electrical power, a real-time prediction system of the output power is significant.
So we propose to develop a website named Turbine Hut, powered by an ML model, where users can predict the wind power by submitting the wind characteristics like speed of the wind and direction which the wind flows. Users can also predict power output for any location by entering their latitude and longitude. The web application can also compare two locations by predicting the output of wind turbine. The application will also be able to forecast for next 6 days of wind turbine output. When coming to speak about the technology stack, we use Python 3.8, React.js, Flask and IBM Cloud as tools and frameworks, and we used LSTM and XGB Boost models for algorithm for building the model. And when coming to deployment, we use Firebase and Heroku. On the first week, we done pre-processing and visualization, and on the second week, we built models to train the data, and in the week 3, we started to build the user interface. In the fourth week, we finished a storage and deployment phase. Finally, we employed our user interface for testing.
So I'll be explaining about the architecture of our project. So first, as a user, we can access our website, and we can register with our user credentials like email and password. Once we registered, we'll receive an email verification link where the user can verify with this email, and once after successful verification, you can log in with those credentials to the website. After successful authentication, you will be navigated to dashboard. So in dashboard, you will be having 4 different modules. So first one is prediction based on location, second one is prediction based on wind characteristics, third one is comparing 2 locations, and last module is forecasting for next 6 days. So under prediction based on location, so user can enter latitude and longitude of any location. So the entered value will be sent to the server. Now server will send the latitude and longitude to Open Weather API, which returns the weather data of the particular location. So server processes the returned JSON file and takes wind speed and wind direction and sends it to the wind energy prediction model. This model returns the wind energy output to the server, and the server returns the output to the user. So now to the front end. So under prediction based on wind characteristics, user can directly enter the wind speed and wind direction, and this data will be sent to server, and server directly sends this to wind energy prediction model, and the calculated result is sent to server, and server sends the data back to the client. So now under comparing 2 locations, here user can enter latitude and longitude of 2 different locations. So these 2 locations are separately sent to server. The latitude and longitude to Weather API, and it returns the weather data of 2 different locations, and the return values sent to our wind energy prediction model, and the result is returned back to from server to the client. Last, for forecasting for 6 days, so we have taken the past data. So once the user enters the latitude and longitude of any location, the data is sent to the server, and server sends the latitude and longitude to weather API. So the weather API returns forecast data for next 5 days at 3 hours gap. This data is sent to LSTM pre-trained LSTM model. It's a deep learning model which forecast it for next 10 hours. So like totally we have forecast for next 6 days, and this data is returned to the server. So this is the overall architecture of our project. So next comes the exploratory data analysis part. Here we found our primary data set from Kaggle, which has 3 independent variables: wind speed, wind direction, and theoretical power. So theoretical power was least important logically, and wind speed was the most affecting one. It seems as it is directly proportional to the wind energy output. So this is the heat map between the attributes. So now the ML models which we have tested for predicting the wind energy output are linear regression, random forest regressor, XGB boost regressor, decision tree regressor, and SVR. So actually, like once we selected those regression models, we started checking the matrices of each model and compare among itself. So here the matrices are R2 score and root mean squared error. So we had more R2 score for XGB boost and less root mean squared error for XGB boost compared to other models. So we also tuned we also did hyperparametric tuning for XGB model, and still the accuracy was, the R2 score was very less. So we took the normal XGB model. So this is the R2 score, and this is the metrics for our model. And then we also tested with ensemble ML model, which has voting regressor. So this ensemble machine learning model has been built with linear regression, random forest, XGB boost, and decision tree regressor, and SVR. So this R2 score is around like 91 point something, so it's around 92. So we gone with XGB boost and did training with XGB boost, and then took the pickle file. So now when it comes to forecasting, so we have forecasted next for next 6 days at 3 hours gap. So we had forecasters for wind speed, wind direction, and this calculated wind speed and direction we pass it into that pre-trained XGB boost regressor. So it generates wind power output for next 6 days, and this is sent to the client. Now this is about LSTM model. So it is a recurrent neural network which has networks with loops in them, allowing information to persist. The very same reason why we have used this model is to predict wind speed and wind direction output. So we have two models. One is to predict the wind. So we pass it twice to predict wind speed, and the other one is to predict the wind direction. The forecasted data for wind speed and wind direction is fed into XGB model, and the output is predicted for next 6 days. So this is the user interface for our web application. So we have latitude and longitude to get the output for any location, and the predictions can be visually separated. Like we have graphs in our website which are for visual representation, and we can also predict for future. A weak output can be forecasted and predicted. So now Sethu Bharati will be showing the demo part.
I'll be walking you through our website. So at first we have to sign up into our website. So once you signed up, you will get a verification mail to your Gmail. So once you verified, you can log in into our website and predict your output for wherever. So let's verify our mail. Yeah, it's verified. So let's log in. Once you log in, you will be redirected to this dashboard. So where you can find 4 screens. So this screen is for to predicting manually. Like you have to go to the location and you have to measure the wind speed and wind direction there, and you can predict here. So let's input the values. And when you click the prediction complete, our model will give you the wind power based on your wind speed and direction. So it is for manually. So we also have another option called predict location, so where you can enter only the latitude and longitude of the location. So our place is like 11 and 77, so let's enter it. So here it is. So for my place, for the latitude 11 point something and 77 point something, our model has predicted output of 28.83. So by using this screen, you can predict for remote places without actually going to the state and measuring manually. Instead, you can input some latitude and longitude, and we have comparing two locations. So here you can compare two locations, like entering the latitude and longitude. Here you can compare what is the current power. Like you can compare for two locations by giving latitude and longitude, and we have another option called predict for next week. So what will it does is, if you enter a latitude and longitude, it will fetch for 5 days of data from Open Weather API, and our model will predict for the 6 days. So in total, we can show the full data for 6 weeks. Complete. So you can get data for 6 weeks
6
with
days.
the interval of 6 days with the interval of 3 hours. So you can see now from 11th from 21 November to 25th November for 6 days at an interval of 3 hours. So here you will be getting what is the wind speed, what is the wind direction, and what is the wind output power. So you can compare all with the graph. So here it will be mentioned with the timestamp. So here it is a wind direction, so it is really large, so wind speed is not visible. So now, yeah, the wind speed is visible. So wind speed is really too small to be visible with the wind direction. So you can visualize with a 3-hour gap, and below you can visualize the wind power, like with a 3-hour gap. So if you want to really check all the statistics of location for 6 days, our website will be really helpful to do that. So you can go back and enter as many locations as you want. So that's it, the walkthrough of our website.
So I will be explaining the future scope. So first one is robust. In our model giving good results, we can add robustness to it by do the prediction for a greater time in the futures. So next is more parameters, trying to achieve more better predictions by considering other features like humidity and climate changes to position of a game. So final one is functionality. Our model can be scaled to be used by governments by training our model with their data with better enhancement.
This is our project. If you have any queries or questions, feel free to email your query. That's it. Thank you.